Now I'll say a few things about short circuits. In a short circuit, the key idea is that the current bypasses the load. So the electricity flowing through never actually gets to the device that it was intended to power. And it bypasses that and essentially takes a shortcut. And I'll give you an example. Suppose you wanted to put a fan on your desk to keep cool. So you've got your electrical outlet over here, and you plug your fan in, and the wire runs across to your fan. So let's draw a fan over here. Fan looks something like this. Some blades that spin around. Usually a row of buttons here. You can control the speed. Now realize that this wire here is actually two wires, and if you look closely at an electrical wire, you can see that it's really two wires bound together. They never touch. There's plastic wrapped around each strand, but they never touch. Now suppose you plug this fan in and you run the wire, which is really two wires. You run it across the room. The fan's on the other side of the room because all your outlets are over here were used for your computer and your stereo and stuff like that. So you needed to use this outlet over here for your fan. So this wire's running across the room, and you realize, well, that's no good. The wire's running across the room. People are going to trip over that, and maybe you trip over it yourself a couple of times and pull the fan onto the floor and all this stuff. It's no good. So you say, okay, well, I'm just going to put the rug over the fan. So you take your rug and you lay it, I'm sorry, over the wire, not over the fan. So you lay the rug down, and so it kind of holds the wire down and keeps you from tripping over it. It keeps the wire out of sight. Everything looks good and everything's working fine. You've got your fan on your desk. It's keeping you cool. You've got your rug there and everything's cool. And after a while, you forget about it. And people come in and out of your room every now and then. You go in and out of your room every now and then. There's foot traffic across this carpet. And foot traffic, people stepping on the wire. Over time, that traffic might begin to wear down some of the plastic coating on those wires. So maybe your door opens right here and people always walk in right in one spot. And so the wires always get stepped on right there. They get ground against a hard part of the floor, and eventually what happens is you might get the wiring worn down in that spot, or the plastic insulation around the wiring worn down, such that the metal strand on one side touches the metal strand on the other. So on a close-up, if you picture say here's the plastic insulation, and inside you've got wires running through here. But if all of this gets crunched and worn down from being stepped on, so you end up with one wire coming into contact with another, that's going to be a short circuit. What's going on is this. Think of electrons coming out of one side of the socket, going to the fan. They go to the fan along one wire. They make the fan turn, and they come back along the other wire. Remember why electrons flow. They're trying to get from one side of this electrical outlet to the other. Remember, the electrical outlet has two little holes here. The electrons are trying to go out one hole, and they're trying to get into the other hole. And when they come down this wire, they get to this point right here where the wires now touch. And the first electron in line says, oh, wow, I can take a shortcut. I don't have to go all the way over to the fan. I can turn around right here and head straight back and get home quick. And they like that, and they do that. And this first electron goes, and he tells all his friends, and they all go, and they all end up taking the shortcut, and they never go through the fan. The fan quits working. It stops spinning. Instead, this is what's called a short circuit. The electrons have taken a shorter path than they otherwise would have. That's why it's called a short circuit. And this can be pretty dangerous. Remember, these electrons have a lot of energy. They would have normally spent that energy in the fan. They are now spending all of that energy in this section of the wire, the section of the wire that they're going through. The fan has a lot more electrical resistance than this section of the wire. And when they just go through the wire, they don't encounter all the resistance of the fan. What happens is a lot more current flows through this wire than otherwise would. And so much current can flow through the wire that it can very easily heat the wire up, melt the plastic around it, set the plastic on fire, set the whole house on fire. A short circuit is usually very dangerous. It's usually the result of a problem or a malfunction. It's not usually something that is done intentionally. It could be in some special circuits, but usually would be done in something, usually would occur when there's a problem. You can also think of it like this. Electrons are trying to get from one side of the outlet to another. They're trying to get from a place of higher electrical potential to a place of lower electrical potential. And it's a lot like water flowing downhill. If you have a mountain and you have some water that's going to flow down the mountain, it's going to roll down the mountain, it's going to wind its way down seeking the easiest path to the ground. It's not going to flow down and then go up here for a little bit and then go down. It would never do this upward leg unnecessarily. It's going to find the easiest route down to the place of lower gravitational potential. The electrons do the same thing. They are going to take the easiest route from one side of the electrical outlet to the other. They're going to find the easiest route from a place of higher electrical potential to a place of lower electrical potential. And so when they encounter this spot in the wire where the two come into contact, then they are going to take that route because it's easier than going through the fan. The fan has a lot of resistance. That would be much harder. They're going to take the easiest route back to the other side of the electrical outlet. Short circuits could occur not just because of wear and tear on a wire like this, but for other reasons. Say you have a computer, a home computer or something like that, and there's a lot of screws inside there that are holding the hard drives in place, or the CD-ROM, or the main board, or the power supply. Suppose one of these screws came loose and touched some metal and some other metal and made a metal-to-metal contact that otherwise wasn't there. That loose screw could cause a short circuit. Or say you dropped something, say you dropped your stereo or something like that. That could cause a wire inside to break loose. And that wire might then flop over and touch something else that it wasn't intended to touch, and electricity could be flowing through some other path, not where it was intended. That could cause a short circuit. There's a lot of different things that could cause a short circuit. And most of them are things that are going to be a problem, not intentional.